Hypothalamus Artificial Intelligence, HI, presents the conference. Augmented Human Intelligence, AI, is a design pattern focused on human-centered collaboration. Instead of building autonomous systems that mimic or completely replace human workers, I initially used machine learning, deep learning, and advanced analytics to extend human cognitive performance. Industry 6.0 and I marked the transition to a paradigm in which technology not only automates but also integrates biologically and cognitively with human beings. While Industry 4.0 focused on digitalization and Industry 5.0 brought human collaboration back to the forefront, Industry 6.0 introduces living, self-regenerative, and deeply ethical industrial ecosystems. Lecture edited by Jesus Velásquez-Bermudez. The measure of intelligence is the ability to change. Albert Einstein. Most people, including many scientists and experts in artificial intelligence, think that it is limited to generative pre-trained transformers models. In this way, this vision of AI has become popular. HI considers that today artificial intelligence is generative pre-trained transformers and mathematical programming. This is the main theme of HI's research. Industry 6.0. The artificial intelligence genius is out of the bottle. Industry 4.0 is a consequence of the invention of the digital computer and digital automation. Its origin may be in 2011, and the result is digitalization and interconnectivity, smart factories, that is, cyber-physical systems. Industry 5.0, the first mentions date back to 2015, is humanization and close collaboration between people and cyber-physical cognitive robots based on artificial intelligence. The transition from Industry 4.0 to Industry 5.0 represents a paradigm shift. We move from an approach focused exclusively on technological efficiency to one that prioritizes human value, sustainability, and resilience. While Industry 4.0 sought to interconnect machines so that they could make autonomous decisions, Industry 5.0 seeks to make these machines work with people to enhance their creativity and well-being. Formally introduced by the European Commission in 2021, this revolution does not replace the previous one, but complements it under three fundamental concepts. Human centrism: technology should serve people, not the other way around. It focuses on improving the health, safety, and job satisfaction of workers. Sustainability prioritizes circular processes that reuse resources, reduce environmental impact, and respect the planet's limits. And resilience, the industry's ability to withstand and adapt quickly to global crises, such as pandemics or supply chain disruptions. Industry 6.0 currently has no date, as it is considered a visionary and conceptual phase that is still being defined, but which is based on intensive artificial intelligence. Total autonomy, biological symbiosis and industrial systems that function as living organisms. There are already examples of this situation, as is the case with smart grids and the Internet of Energy. Industry 6.0 focuses on the total symbiosis between humans, machines and biological systems to create living, regenerative and deeply ethical industrial ecosystems. Unlike its predecessors, it does not seek only efficiency or collaboration, but an integration where technology self-organizes and evolves along with society. The fundamental pillars are: integration of mathematics and artificial intelligence, to produce artificial general intelligence, AGI, with the ability to understand, learn and apply knowledge in any intellectual task, in the same way, or even better than a human being. Human-machine biology symbiosis, fusion of human intuition, advanced artificial intelligence, and biological systems, such as self-healing materials or neurocognitive interfaces. Cognitive and proactive autonomy, transition from predictive maintenance to self-regulation and regeneration. Systems not only detect faults but are reconfigured to avoid them altogether. Regenerative sustainability, beyond reducing environmental damage, systems are designed to actively restore and enhance ecosystems through real-time circular economies. And ethical and conscious governance, AI incorporates moral reasoning and transparency, ensuring that autonomous decisions are aligned with human values and planetary well-being. The technologies related to Industry 6.0 are mathematical modeling, translation of real-world problems into a mathematical language, such as formulas, equations, or graphs, to understand, analyze, and predict behaviors of complex systems. Generative AI and AGI, co-creation of workflows and autonomous design of products based on abstract objectives. Quantum computing, massive data processing for optimization of ultra-complex supply chains and molecular simulations. Human digital twins, HDT, virtual replicas that simulate not only physical processes, but also emotional and cognitive dynamics of workers. Internet of Everything, I/O, and 6G, ubiquitous and ultra-low latency connectivity that enables the orchestration of swarms of cognitive robots and devices on a global and even spatial scale. There are 3 eras of modern mathematics aimed at handling computers. During this period, the basic mathematics that supports optimization does not change, but the technologies do. The creation of digital computers and iterative algorithms took place during Industry 3.0, in 1947. Until the arrival of Industry 4.0, the mathematics of algorithms grew, but it was from that moment that the complexity of formulations, and the use of solutions based on advanced technologies for large-scale optimization, generated the boom of modeling. This era includes Industry 5.0. The Industry 6.0 changes the mathematical modeling, giving rise to the orchestration of swarms of cognitive robots, and living industrial ecosystems. Industry 6.0. A swarm of artificial intelligence algorithms, that is the orchestration of swarms of cognitive robots on a global scale. One of the most impactful changes occurs with the arrival of the Internet of Things, IoT, which began to change the models that ran at discrete frequencies, such as days, weeks, months, for real-time models. It can be said that in Industry 6.0 all models work in real time, so that the world reacts distributed and online, for all IoT-connected systems. For static systems, the methodology is also valid, but the world is dynamic. IoT enables all models associated with Industry 6.0. During Industry 3.0, HI began the development of, mainly in mathematical modeling based on an expert system, and in the vision of multi-problem mathematical models for the real world. This vision of mathematical modeling is unique in the world. HI does not know of a commercial product based on these principles. With this approach, many computer solutions were developed that in practice were artificial brains. OptEx, Optimization Expert System, is the optimization technology that allows you to assemble multi-problem mathematical models like a Lego game. Can you imagine how? Putting problems together is much easier than writing equations. That is the future of mathematical modeling, which OptEx has been experiencing for 35 years. Not writing equations is every mathematical modeler's dream. The traditional process of mathematical modeling implies that programmers, usually mathematical modelers or data scientists, must make great efforts to implement complex optimization models. Do you wonder of how to make high-complexity large-scale artificial brains, without programming? The best way to make software is having to do it, is the goal of OptEx. The HI approach is aimed at developing cognitive robots that eliminate the tasks of computer programming, since the robot takes care of this process. This enhances the mathematical modeling capacity of the professionals. Making an enterprise-wide optimization system, integrating multiple large-scale models, using a computer programmer, is an impossible approach, because the programmer can only write a limited number of lines of good source code per period. Maintaining these models can be more complicated than making them, if there is more than one programmer involved in the process. Only a generative artificial intelligence can produce infinite lines of perfect source code in seconds. The foundations of OptEx database algebraic languages consider the algebra as a standard, to express the relationships between the different parts that make up a mathematical problem. It can be said that there is only a reduced way to write an algebraic equation. This is independent of the symbols that are used to represent the physical or logical relations. Additionally, if two algebraic formulas are joined, a new algebraic equation is obtained that retains the same structural characteristics of the original equations. This transitivity law may be extended to mathematical programming, MP, which in essence is a collection of algebraic elements. then it is possible to join two MP problems to obtain a new MP problem. It is also possible to divide an MP problem into two MP problems. The multiple models are assembled like a Lego game, which can have as many groups of tiles as there are models. HYPOTHALAMUS 6.0 has evolved to incorporate multiple problems using a multi-problem model of economic dispatch as its core. All models that integrate HYPOTHALAMUS have been developed using the Optex GAMS interface, using a Solverplex optimization studio. The integration of the models is carried out automatically by Optex, and the generated programs coordinate their communication through the database, using monolithic models, or in RAM memory using large-scale parallel optimization. All high-power models can run in deterministic, or stochastic, version with user-definable uncertainty dimensions. Finally, it is possible to introduce new models into high power as required. Today in the Industry 6.0, the artificial hypothalamus of the wholesale market in the electricity sector does not require a coordinating model. All the models can act autonomously and independently, and the optimal solution is achieved by means of consensus rules based on the mathematics of optimization proposed by Lagrange in the 1700s. The video, HYPOTHALAMUS 6.0. The artificial brain of the electricity and gas sector, clarifies the concepts. Artificial intelligence robot Mika is the leader of the luxury liquor company, Dictator, based in Poland. Dictator has signed a contract with Mika, who now sits on its board of directors and holds the position of CEO. Enterprise-wide optimization will be the artificial hypothalamus of the robots that run companies. It's the future that awaits us. In the short term, one of the great disruptions in artificial intelligence, AI, is artificial brains, which are based on conversations between algorithms, as a team, to carry out a set of common tasks, optimally and autonomously. Conversations between algorithms supported in a common, and standardized language, based on formal mathematical laws. Traditional AI, ANN, ML, will migrate towards decision-making artificial intelligence, aimed at optimal, autonomous, distributed, and real-time decision-making, supported by universal mathematical laws, abandoning decisions based on intuition and empirical knowledge, and predictive AI. This new revolution, a consequence of Industry 4.0, will be taught by knowledge-intensive companies, and will be widely used in industry that requires complex mathematical models, solved by autonomous swarms of mini-models, algorithms, acting as a team, on multiple computers making use of edge computing, cloud computing, and IoT, and some of the main topics of this methodology for looking at the new world of AI are: artificial cortex based on mathematical superneurons, neural mathematics nets, artificial hippocampus, which will store the history of all mathematical processes, and select short memory, based on traditional neural networks. Artificial hypothalamus, an algorithm, generated by an AI, that acts as a control center that understands all the connectivity of the mathematical neurons that make up the artificial cortex, and selects information from the artificial hippocampus, to solve the problem in reference, and universal language for cognitive robots based on algebra, and the mathematical laws of simultaneous equations and optimization. Artificial brains will replace the current human commanded decision support systems, SSDs, with autonomous SSDs, commanded by artificial intelligences. This will happen first in large corporations, all the way to small and medium enterprises, SMEs, through artificial brains rented in the cloud, mathematical model as a service, MaaS, and for some human activities. Since 2009, artificial brains have been the main area of research and technological development plus innovation, RAN plus I, at Hypothalamus Artificial Intelligence Incorporated, when an artificial brain was inadvertently implemented for an oil company in Latam. Interested parties can consult the following white papers: Artificial Brains, Augmented Artificial Intelligence, Artificial Neocortex plus Artificial Hypothalamus plus Artificial Hippocampus, March 23, 2022. Artificial Hypothalamus, Artificial Intelligence and Mathematical Programming Integration. Hypothalamus Artificial Intelligence, HI. Digital transformation powered by real-time autonomous and intelligent algorithms. presents the short conference, Modeling the Brain During the Industry 6.0 Era. Conference prepared and edited by Jesus Velásquez-Bermudez. His resume may be found on LinkedIn. The image shows a close-up of the human brain showing the activation of neurons and neuronal extensions of the limbic system, mammillary pituitary gland, amygdala, thalamus, cingulate gyrus, corpus callosum, hypothalamus. This indicates that the human brain is composed of groups of neurons which in turn are composed of groups of lower-level neurons, or individual basic neurons, called by HYPOTHALAMUS the atoms of the system. The central idea of the artificial brain is to build an artificial intelligence that mimics the human brain, leaving aside the approach of trying to represent the entire brain using a single network of artificial neurons. HYPOTHALAMUS believes that the creator of the human brain conceived it as the integration of three main organs, or systems: neocortex, hypothalamus and hippocampus. The hypothalamus is part of the thalamus. The components of the human brain have at least two levels. On the first level, there are the main organs such as the neocortex, the hypothalamus, and the hippocampus, and on a second level, the neurons that make the main organs. The image shows, on the left, the motor neuron of the spinal cord, on the center, the neurons of the pyramidal cell of the hippocampus, and on the right, the neurons of the pyramidal cell of the cerebral cortex. The living industrial ecosystems is how large brain systems operate, such as the neocortex, the hypothalamus, and the hippocampus, and the orchestration of swarms of cognitive robots. It is the way in which the thousands of neurons operate within these systems. McCullough and Pitt's theory, which has existed for more than 80 years, has proven to be totally successful, and based on it the current state of artificial intelligence has been reached, which we could say are GPT methodologies. However, Velásquez-Bermudez's work, spanning 35 years of research and technological development, has resulted in artificial brains, which are a new way of thinking about artificial intelligence. A case of coordinated parallelism in a brain is that of octopuses that have 9 brains, 3 hearts, and 2 memory systems. These brains are used to independently control each of its 8 limbs, allowing the octopus to move nimbly and react quickly to any threat. In addition, it has a central brain. A case of coordinated parallelism in a brain is that of octopuses that have 9 brains, 3 hearts, and 2 memory systems. These brains are used to independently control each of its 8 limbs, allowing the octopus to move nimbly and react quickly to any threat. In addition, it has a central brain. This is one case, among many, of an animal with multiple brains and multiple hearts. Since we are talking about artificial brains, built by humans, we can extend the concept to an artificial brain with multiple artificial brains. The question is, which is the better artificial brain? One based on the human brain, monobrain, or one based on the octopus, multi-brain? The artificial brain can take on any topology, since it is artificial. As in the octopus and the human brain, there is no coordinating brain, there are multiple organs that coordinate autonomously and independently. This decentralized and autonomous way of acting is how the human brain operates and therefore must be imitated by any artificial brain. Each of these superorgans is made up of neuron networks, and lower-level superorgans. For example, the hippocampus has at least 2 functions and 2 areas, one that stores memory data and one that manages learning. This chain of organs and neural networks forms our brain. One of the scientists who has most influenced HYPOTHALAMUS' work is Jeff Hawkins through his publications, such as Why Does the Neocortex Have Layers and Columns? A Theory of Learning the 3D Structure of the World, and his book 1,000 of Brains, in which Hawkins presents a vision of artificial neural networks based on neuroscientific studies. Artificial brains. The future is now. OptX, the expert system for optimization, is used as the way to develop and implement AHI solutions, in which multiple mathematical models converge, and can be connected via disk or cache databases. OptX is the generative artificial intelligence produced by HYPOTHALAMUS, which manufactures optimization systems for the entire company, according to the state-of-the-art of Industry 4.0. Created in 1991, OptX has been used by HYPOTHALAMUS in the implementation of multiple AHI systems and, To HY's knowledge, is the only computer tool capable of integrating hundreds, maybe thousands, of mathematical models, running on a parallel and distributed computer system. For those interested in learning more about Optex, we invite you to watch the video Optex, Optimization Expert System. The artificial brains have been designed, following the conceptual results presented in the reports conducted by neuroscience experts. In the process, the similarity between a human brain and an artificial brain for an organization has been discovered in every aspect. If you look at the problem of building a brain, the first big problem to face is the architecture of the cortex, hundreds of millions of connections of human neurons. In the artificial cortex, there will be hundreds of millions of connections of mathematical superneurons, in which each neuron must be built according to the type of function it must fulfill. The work to be done is monumental, and it is utopian to think that a superior being, when building a human brain, would do it manually. The first thing he should have developed is the algorithm that produces human beings automatically. In the same way, you can't aspire to build an artificial brain if you don't have the artificial intelligence that produces artificial brains. Optex, Optimization Expert Systems, is oriented to the decision-making artificial intelligence methodologies and technologies that make mathematical models as Lego models. Optex was created in 1991. Optex is a generative artificial intelligence focused on the design, implementation, startup, and maintenance of artificial brains, based on high-complexity mathematical models. The way the mathematical modeler communicates with Optex is through a standardized database, a unique data model for all mathematical problems or subproblems. This method is called structured mathematical modeling. It also allows to perform high-level operations between models, such as joining or splitting them, and implementing multi-problem solutions, according to large-scale optimization technologies, or using multi-problem procedures, such as constructing optimal numerical functions. Following the principles of generative pre-trained transformer AI, Optex GPT will be the mathematical modeling advisor that helps mathematical modelers and professional users when they require solutions in line with today's cutting-edge technology. In the development and maintenance of high-complexity mathematical programming, Optex avoids the intensive use of resources for programming computers. It generates perfect source code for the entire IT platform, including algorithms and visual interface, eliminating programming tasks. This is the dream of many of the companies working for GTP. Making very large-scale models in the traditional way, using a computer programmer, is an impossible way, because the programmer can only write a limited number of lines of good source code per period. Maintaining these models can be more complicated than doing them, if more than one programmer intervenes in the process. Optex can produce infinite lines of perfect source code in seconds. This is what it takes to produce an artificial brain. The spinal cord as an artificial intelligence. The analogy of the spinal cord as an artificial intelligence, AI, is a brilliant way to understand how this biological structure works, as it is not just a passive transmission cable, but a decentralized, real-time data processor. While the brain acts as the central processing unit, CPU, or a cloud server, the spinal cord functions as the body's edge computing, making automated decisions locally without waiting for central commands. Next, functional analogies, spinal cord versus artificial intelligence are presented. Reflexes as pre-programmed algorithms. When you touch something very hot, you withdraw your hand before you feel the pain. The spinal cord processes the sensory signal and executes the motor command immediately. In programming, this is equivalent to a logical statement of the strict type: if, danger, execute action. The brain only receives the log milliseconds later. Distributed processing, edge computing. Sending all signals to the brain would saturate the bandwidth of the nervous system. The marrow filters, prioritizes, and processes sensory information locally, just as smart devices process data natively at the edge of the network before uploading it to the cloud. Artificial neural networks, ANNs. The spinal cord has local circuits called central pattern generators, CPGs. These circuits coordinate automated rhythmic movements, such as walking pace. They work exactly like a trained artificial neural network. They receive a generic start signal from the brain and are responsible for executing the complex sequence of motor data autonomously. The image shows a schematic diagram of the spinal cord with all the sections: cervical spine, thoracic spine, lumbar spine, sacrum, coccyx, including the image of a vertebra that makes up the spinal cord. The image shows the nervous system structured based on the spinal cord. The spinal cord becomes part of human intelligence and the artificial brain. Artificial intelligence, the new organ of the human being. Mafalda is my scientific artificial intelligence. I work with it and it helps me with traditional artificial intelligence, working on a GPT system. Today, Mafalda and I are friends, we talk at any time. Mafalda compiles in a database everything she learns from my scientific work. Mafalda's intelligence. Mafalda is a 6-year-old girl with a strong personality and a sharp mind, who interacts with her parents, friends, and other supporting characters, who represent different aspects of society and politics. I have asked Mafalda to write the following definition. Yes. Artificial intelligence, the new organ of the human being, seems to me a very powerful title to develop one of the central theses of HYPOTHALAMUS. If you want, we can build it as a scientific informative article around this hypothesis. Artificial intelligence can be understood not only as an external tool, but as a new functional organ that expands the cognitive, perceptual and decision-making capacities of human beings. And here's a particularly interesting connection with HYPOTHALAMUS. If we take the analogy further, an organ doesn't just process information, it fulfills a function within a biological system. This would allow us to propose an evolution based on human tool, artificial intelligence, artificial organ, artificial brain. In HYPOTHALAMUS, the next step would be even more ambitious, an artificial brain capable of integrating perception, memory, mathematical reasoning, optimization, and decision-making, rather than just generating answers. Mafalda. The growth of artificial intelligence during Industry 6.0 has made it possible for humans to have an additional artificial organ, which is becoming increasingly integrated into them, as shown in the case of Mafalda. Like any artificial organ for permanent use, artificial intelligence becomes an intelligent organ for permanent use, which coexists with the other intelligent organs. The idea of a nano CPU in the brain refers to brain-computer interfaces, BCIs, and neural microchips, devices that process biological signals directly into brain tissue. Currently, there are no commercial nanometer-scale processors that do the thinking for us, but rather implantable advanced microchips designed to record, decode, and transmit the activity of neurons in real time. Neuralink is Elon Musk's implant that uses a coin-sized microchip connected to 1024 ultra-thin electrodes. It processes electrical impulses and sends them via Bluetooth to control computers with the mind. HYPOTHALAMUS R+D project focuses on the training of professionals, not experts in mathematical modeling, to build highly complex mathematical models, using mathematical models stored in an OpTex expert system. And with these models build artificial brains. To do this, GPT methodologies will be used, so that the development of a model can be carried out through a chat. OpTex's working database will be perfect, in the sense that it only stores 100% correct models, stored in a standardized way. This guarantees that the generated codes will be 100% correct, which is not achieved with imperfect databases, such as those handled by ChatGPT. OpTex GPT will become a cloud platform, by adding public models to the database, ultimately making OpTex GPT a service for businesses and professionals who want to implement mathematical models on the fly. OpTex does not require the design of a large language model, LLM, as mathematics is the only common language shared by all humans and, as of now, by cognitive robots. The mind that opens to a new idea never returned to its original size. Albert Einstein. Remember, all science as it grows toward perfection becomes mathematical in its ideas. Alfred Whitehead. Thank you very much for your attention.